Today we're going to talk about parallel lines and transversals. So parallel lines are two lines that never intersect, meaning they never cross paths. This last example are not parallel because if we continued the blue line and the green line, they would intersect somewhere around here. Now if I had two lines, lines L and lines M, and they're parallel, you'll notice that we have this notation here. This notation just means that these two are parallel to each other. Now if I drew a third line, line N, you'll notice that it intersects with both L and M. This is called a transversal. A transversal is a line that intersects two or more lines. And you'll notice that the transversal creates a series of angles. Now these angles are all related to each other. So here we have angle 1 and we have angle 5. And you'll notice that they're both in similar positions. Those are called corresponding angles. Corresponding angles are noted with this little arc here. That tells you that not only are these angles corresponding, but they are also congruent to each other, meaning they're equal. So if angle 1 has a value of 135, we know that angle 5 has a value of 135 as well. Likewise, you'll see that angles 2 and angle 6 are corresponding. These ones are congruent to each other, so they have the same notation. But you'll notice that the notation is different than that of angle 1 and angle 5. We have two lines instead of just one. That means that angles 2 and angle 6 are equal to each other, however, they are not the same as angles 1 and angles 5. Now angles 3 and angle 7 are another example of corresponding angles, as are angles 4 and angles 8. Now you might have noticed that angles 2 and angles 3 have the same value, however, or as do angles 6 and angle 7, however angles 1, 4, 5, and 8 all have different values. Now, the reason for that is because angles 2 and angles 3 are called vertical angles. So the vertical angles are the angles that are across from each other. So angles 2 and angles 3 are vertical angles, just like angles 1 and angles 4 are vertical angles. Now, using this example, we can figure out the value of the remaining angles. So we're going to start off with this 150 degrees. Now the corresponding angle to this angle here would be angle 5. So we know that angle 5 must be 150 degrees. Now angle 7 is a vertical angle to this angle, so that must also be 150 degrees. Angle 4 corresponds to this angle here, but it is also a vertical angle of this angle, so we know that it must be 150 degrees. The remaining angles then are 30 degrees, because this one here, angle 8, was vertical to our original. Angle 3 corresponds to this angle here, so that is also 30, and then angle 2 is a vertical angle to angle 3, but it's also corresponding to our original, so that is 30 as well. Now, supplementary angles are angles that add up to 180 degrees. So a line L has a value of 180 degrees. It has a measurement of 180. So that means that the two angles that are added into line L must be equal to 180. So if we look at our plane again, and we look at our two parallel lines and the transversal, we'll notice that angles 1 and 2 are supplementary, and angles 1 and 3 are supplementary. Likewise, 2 and 4 are supplementary, 5 and 8 are supplementary, etc., etc. But because of this, we know that all of these different angles there end up equaling 180 degrees when they're added together. So from that, we can then find all of the angles within this plane. So given that this one is 25 degrees, we know that angle 1 is supplementary to it. So therefore, if we subtract 25 from 180, we'll be left with the value of 1, of angle 1 that is, which is going to be 155 degrees. Now if this angle here is 155 degrees, we know that angle 4 must be 155 degrees as well. If angle 4 is 155 degrees, we know that angle 8 must be 155 degrees because it's corresponding. This one's a vertical angle of angle 8, so then this one must be 155 degrees as well, and so on and so forth. So you can see how each of these different angles has a value given these two originals. So now we've talked about parallel lines and transversals, as well as supplementary angles, and we've done a couple of examples that show you how we can find any angle within a plane when we are given two parallel lines and a transversal.